Hello viewers, we are going to consider ordinary differential equation, and under ordinary differential equation we'll consider homogeneous equation. Now looking at the question, you discover the fact that you cannot solve this question using direct integration at this point. You cannot also solve it using separation of variable at this point because this is xy. There is no how you can separate this directly at this point. And so when you see a question of this nature, you think of another method that you can actually solve it. And then if you look at this, the power of x and y is the same. So once you have the power of x and y being the same, you know that you're looking at solving it homogeneously. And so in this question, for homogeneous equation, let me just say that before we start the main solution, we have to understand that the y, the x, is equal to a function of y over x. Function of y over x. And then, at this point, for homogeneous equation, if you want to solve any homogeneous equation, you have to do substitution. And so we'll get to that point where we have to substitute. So let's start the solution. Now, we have to ensure that for whatever we want to do to this equation, that the y over the x will take this form of y over x. And so that is what we want to do. So let's call this equation 1. And so in order for us to get this, okay, let's move this other one, minus x squared dy, to the right hand side of the equation. So when we do that, we are going to have xy plus y squared plus x squared, the x equal to x squared dy. We've been able to move this to the right hand side of the equation. We've done that. And so the next thing is to ensure that we establish this relationship of dy dx equal to a function of y over x. So that's what we need to establish. So in order to do that, we have to first say, okay, divide both sides of the equation. Let's call this equation 2 now. So we say divide both sides of equation 2. Divide both sides of equation 2 by dx. So we say divide both sides of equation 2 by dx. And so if we implement that, we are going to have xy plus y squared plus x squared dx divided by dx equal to x squared dy divided by dx. And so from here we can cancel out. This will be 1, this will be 1. And so our next equation will be, from the left hand side, we are going to have xy plus y squared plus x squared, we can decide to put it in brackets, will be equal to x squared dy dx. Okay? And so let's call this equation 3. So in order to ensure that dy dx stands alone, we divide both sides, or okay, we can say multiply both sides of equation 3 by 1 over x squared to ensure that dy dx stands alone. So multiply both sides of equation 3 by 1 over x squared. And so if we do that, in implementing it in the left hand side, we are going to have 1 over x squared into, because we have a lot of things here, left hand side we have, okay, let's say times, let's put this other one in bracket, xy plus y squared plus x squared equal to, we do the same thing to the right hand side, 1 over x squared times x squared dy dx. And so I haven't done that. It means we can actually cancel out this. Take this out. This is 1, this will be 1. And so if we multiply this through this bracket, it is going to take the denominator of all of this. So we are going to have xy plus y squared plus x squared divided by x squared equal to dy dx. That's what we are going to have in the right hand side of the equation. So we can, for the sake of convenience, we can decide to take this to this side and this to this side. So we'll have dy dx equal to xy plus y squared plus x squared all over x squared. So we've been able to establish this, that dy dx equal to y over x. So we've been able to at least get to this point, but we have to move further. Now, I said earlier that in homogeneous equation you have to do substitution, and that substitution entails making a mathematical statement. So at this point, let's call this equation A. So at this point of equation A, we have that, at this point of equation A, we have that y over, that dy dx is equal to a function of y over x. So we will definitely make a substitution at this point so that it will enable us to solve our question. So at this point we can say, let v equal to y over x here. Now let v equal to y over x. And so if v equal to y over x, then if you cross multiply, your y will be equal to vx. This is very important. These two equations are very important. Okay, we can call this equation 4 and call this equation 5. These equations are very important. If we say let v equal to y over x, we are getting it from this point, and then y, because when we cross and make y subject of the formula from equation 4, we'll have that our y will be equal to vx. So we've achieved that. We have to move on. Now, what this implies is wherever you see y, you put vx. But before we do that, let's call this, let this be our equation 4, let this be our equation 5, and let this be our equation 6. Now, we have to do something with this equation 6. So, you say from differentiate y with respect to x in equation 6. So this equation 6, we are going to differentiate y with respect to x. So if we differentiate y here, it will give us dy dx equal to, now this is vx, we are going to apply product rule to differentiate this one. So we keep v constant and differentiate x. When we differentiate x, it will be 1, so we dot 1, which is the same thing as times 1, plus we keep x constant and we differentiate v, and because we are differentiating with respect to v, v will be dv dx, so that our dy dx will now be equal to v times 1 is v plus x dv dx. So we can call this our equation 7. So now there's something you have to understand. We have that in equation 4 that dy dx equal to this, and equation 6, in equation 7 rather, we've been able to determine the value of dy dx. So we are going to put the value of dy dx we have in equation 7 into equation 4. So this is now the value of dy dx. So we'll bring it into this equation. So and we make a mathematical statement, put the value of dy dx, with the value of dy dx in equation 7 into equation 4. So what it means is I'm going to take this and replace it here, so that our new equation becomes v plus x dv dx will be equal to, this is xy plus y squared plus x squared divided by x squared. So we've been able to do this now, that we've been able to take the value of dy dx in equation 7 and then we put it in equation 4. So we've achieved that. So now we have to also remember that, okay, let's come to this end and continue. Let's continue it from this end. And we don't need this again. So now recall that y equal to vx. So what this implies is anywhere we see y in, let's call this equation 8. Anywhere we see y in equation 8, we substitute that value with vx. So from the left hand side of equation 8, we are going to have v plus x dv dx equal to, from the right hand side we have x first, and it is multiplying y. So because y is vx, you put vx there plus, we have the next one is y squared, and y is vx, so we have vx, and because it is raised to power 2, we raise it to power 2, plus we have x squared again divided by the denominator, which is x squared. And so we move on, x dv dx equal to x times vx will give us vx squared plus vx all raised to power 2 will give us v squared x squared, plus we still have x squared here, we divide it by x squared. Now if you look at the right hand side of the equation, you observe that x squared is common here, is common here, is common here, so we can factorize. So when we do that, we have this. So for the right hand side of the equation, we bring out x squared. If we bring out x squared from this point, we are going to have v left, plus if we bring out x squared from here, we are going to have v squared left, and then if we bring out x squared from here, we are going to have 1 left, and we divide it by x squared. So we can cancel out this, and so our equation will now be v plus x dv dx equal to v plus, this is 1, this will cancel out 1, v plus v squared plus 1. We can call this equation 9. And so having achieved this, we have to ensure that we move v to this v to the right hand side of the equation, and in order to achieve that, we make a mathematical statement: subtract both sides of equation 9 by v. So this means from the left hand side we are going to have v plus x dv dx minus v equal to, then from the right hand side we have v plus v squared plus 1 minus v. So if we look at here, v minus v here will give us 0, and v minus v here will give us 0 too, so that we'll have our equation, now to be, from the left hand side we'll have x dv dx equal to, and then from the right hand side we have v squared plus 1. So that is all we have. From the left hand side we have x dv, okay, let me from the left hand side we have x dv dx, and then from the right hand side we are going to be left with v squared plus 1. I think we are beginning to get to the end of the question, but we continue. Now what we have to do is to ensure that v, anything that has to do with v stands alone, and anything that has to do with x stands alone. And note, the x will be in the right hand side, the x will be in the right hand side, while the v, whatever, will be in the left hand side of the equation. Always note that. So in order to achieve that, since the x will go to the right hand side, we have to ensure that we do all our mathematical manipulation to ensure that x goes to the right hand side of the equation. So we can call this equation 10. So we say, let's start by saying multiply both sides of equation 10 by the x. And so if we do that, we are going to have dx dv dx times dx will be equal to v squared plus 1, and let's say times dx. Okay, and so this will cancel out, so we'll be left with x dv equal to, from the right hand side we have v squared plus 1 dx. So it's the same thing as n times the x, so we keep it that way. And so the next thing is for us to move this x to the right hand side again. So we can now say, let's call this equation 11. We can now say multiply both sides of equation 11 by 1 over x. So the essence is to eliminate x in the left hand side, while we take it to the right hand side of the equation. So we have 1 over x times, for the left hand side, x dv equal to, for the right hand side we have 1 over x times into v squared plus 1 dx. So we can cancel out here 1, and so we have our dv to be equal to, this will be 1 over x into v squared plus 1 dx. We can call this equation 12. And so we move on with our solution. So continue, and then we have to ensure that we also move v squared. Let me write this properly. This is v squared plus 1. So we have to ensure that this v squared plus 1 gets to the left hand side of the equation. And so in order to achieve that, we can say multiply both sides of equation 12 by 1 over v squared plus 1. So we say multiply both sides of equation 12 by 1 over v squared plus 1. So if we implement this mathematical statement, we are going to have 1 over v squared plus 1 times dv equal to, that's for the left hand side. Then for the right hand side we have 1 over x into, okay, let's say 1 over v squared plus 1 times 1 over x into v squared plus 1 times dx. Okay, let me write this properly. V squared plus 1. So if you look at here, this can cancel out, this will cancel out, and so if you say 1 over v squared plus 1 times dv, this will give you dv over v squared plus 1 equal to, and then at this point we have 1 over x dx. So we say This is 1 over x times the x will give us the x over x. Okay, so we can do this way. We can separate it so that it will help us in integration. Now, before we integrate it, this is what we've done. We've been able to separate the variable. We've been able to ensure that everything that has to do with v stands in the left hand side, and everything that has to do with x stands in the right hand side. So at this point, we can now introduce our integral sign. Let me write this properly. We can now introduce our integral sign, or we can now integrate. But before we do that, we have to separate so that we have 1 over v squared plus 1 dv is the same thing here, equal to 1 over x dx is the same thing, so that we can now apply our integral sign. So let's call this equation 13. So we say integrating equation 13. So if we integrate equation 13, we introduce the integral sign. 1 over v squared plus 1 dv will be equal to, we integrate 1 over x dx. Okay, let's move to this other side to continue our solution. It's quite a lengthy one. We'll soon be done. So if we integrate, this is a standard integral. 1 over v squared plus 1 is a standard integral. In standard integral, if you have integral of 1 over x squared plus 1, this is equal to tan x. So it's a standard integral. So if you integrate this, you are going to have tan x. Okay? But because we are dealing with v, so it's going to be tan v. So this is a standard integral. 1 over v squared plus 1 is a standard integral. So because we are dealing with v, like I said, integral of 1 over x squared plus 1 is equal to tan x. That is the integration. So if we integrate 1 over v squared plus 1, okay, let me write it. Integral of 1 over x squared plus 1 equal to tan x. So which means, okay, note, okay, so but since we are dealing with v, our answer is going to be tan v, yes. So we are going to have, when we integrate 1 over v squared plus 1, we are going to have tan v equal to, when we integrate 1 over x, we are going to have ln x. Remember, you always add your c, which is constant of, integration. Recall that we said that v equal to y over x. Recall from when we started this solution that v equal to y over x. So wherever we have v, we are going to bring in y over x. So this will give us tan into y over x equal to ln, let's put this x in brackets, plus c. Okay, so since we've gotten this, we can now say, we can decide to, if we want to find, okay, let's cross multiply. If we cross multiply at this point, we have that tan y will be equal to x into ln x plus c. That is, x is coming to multiply this. But then we are not looking for tan y, we are looking for y. And so if we are looking for y, we have to divide both sides of this equation by 1 over tan. So if I call this equation, if I call it equation 14, I can say divide both sides of equation 14, divide both sides of equation 14 by 1 over tan. So we are going to have, okay, multiply, yeah, it's going to be multiply, sorry. So when we do that, we are going to have 1 over tan for the left hand side times tan y will be equal to 1 over tan, we have x times x into, we have ln x plus c. Okay, so we continue, we'll soon be done. Continue. So this will cancel out this, and so we are going to be left with y equal to 1 over tan 1 over tan times x will give us 1 over tan x into, we have ln into x plus c. Okay, now we know that from indices 1 over a is the same thing as, from indices 1 over a is equal to a raised to power minus 1. Therefore 1 over tan will be equal to tan inverse of 1. So which means here becomes tan inverse. So we are going to have y equal to tan inverse of, okay, let's say dot x, which is this x, into ln into x plus c. So we can decide to take our x down here, so that we have that our final solution is y equal to this x, we have it here, x tan inverse into ln x plus c. So viewers, this is our answer. This is the final answer, the final solution to the question using a homogeneous equation. Is always a long one when it has to do with homogeneous equation, but the steps I have followed are the standard steps you follow whenever you're solving questions on homogeneous equation. That's the standard step. So thank you for watching.